Properties of materials. The matter is anything that has mass and occupies space. A useful way of start thinking about the matter is to think about the different materials or substances that it can be made into. These materials make up the objects around us, and each of this material has different properties or characteristics that can be observed or tested. The mechanical and the physical properties of materials are determined by their chemical composition and their internal structures, like grain size or crystal structure. Mechanical properties may be greatly affected by processing due to the rearrangement of the internal structure. Metalworking processes or heat treatment might play a role in affecting some physical properties like density and electrical conductivity, but those effects are usually insignificant. Let's discuss some common mechanical and physical properties. Conductivity. Thermal conductivity is a measure of the quantity of the heat that flows through a material. It is measured as 1 degree per unit of time, per unit of cross-sectional area, per unit of length. Materials with low thermal conductivity may be used as insulators. Those with high thermal conductivity may be a heat sink. Corrosion resistance. Corrosion resistance describes a material's ability to prevent natural, chemical or electrochemical attack by the atmosphere, moisture or other agents. Density. The density of the alloy will determine how much a component of a certain size will weigh. This factor is more important in applications like aerospace or automotive where weight is important. Engineers looking for lower weight components may seek alloys that are less dense, but must then consider the strength to weight ratio. A higher density material like steel might be chosen, for example, if it provides higher strength than a lower density material. Such a part could be made thinner so that less material could help compensate for the higher density. Ductility or malleability. Ductility is the ability of a material to deform the plastically, that is, stretch without fracturing and retain the new shape when the load is removed. Think of it as the ability to stretch a given metal into a wire. Elasticity. Elasticity describes a material's tendency to return to its original size and shape when a distorting force is removed. The stiffness of a metal is often measured by the Young's modulus, which compares the relationship between stress, the force applied, and the strain, the resulting deformation. The higher the modulus, meaning greater stress, result in proportionally lesser deformation, the stiffer the material. The glass would be an example of stiff, high modulus material, whereas rubber would be a material that exhibits low stiffness, low modulus. Fracture toughness. Impact resistance is a measure of material's ability to withstand a shock. Certain metals may perform acceptably under static load, but fail under dynamic loads or when subjected to a collision. Hardness. Hardness is defined as a material's ability to resist permanent indentation, that is, plastic deformation. Typically, the harder the material, the better it resists wear or deformation. Plasticity. Plasticity is the converse of elasticity. It describes the tendency of a certain solid material to hold its new shape when subjected to forming forces. It is the quality that allows materials to be bent or worked into a permanent new shape. Strength fatigue. Fatigue can lead to fracture under repeated or fluctuating stresses, for example, loading or unloading, that have a maximum value less than the tensile strength of the material. Higher stresses will accelerate the time to failure and vice versa. So there is a relationship between the stress and cycles to failure. Fatigue strength is an important consideration when designing components subjected to repetitive load conditions. Strength shear. Shear strength is a consideration in applications like bolts or beams, where the direction as well as the magnitude of their stress is important. Strength tensile. One of the most common metal property measure is tensile or ultimate strength. Tensile strength refers to the amount of the load a section of metal can withstand before it breaks. Strength yield. Similar in concept and measure to tensile strength, yield strength describes the point after which the material under load will no longer return to its original position or shape. Deformation moves from elastic to plastic. Design calculation includes the yield point to understand the limits of dimensional integrity under load. Toughness. Measured using the Charpy impact test similar to impact resistance, toughness represents a material's ability to absorb impact without fracturing at a given temperature. Since impact resistance is often lower at low temperatures, material may become more brittle. Wear resistance. Wear resistance is a measure of a material's ability to withstand the effect of two materials rubbing against each other. Processes such as mixing, heating, and cooling can change materials and their properties. This can be useful as the new properties may be better suited for the particular purpose. For example, mixing certain metals can create a material that is both strong and lightweight.